Hi and welcome to this video. So we're going to look at redox experiments, and this experiment number 2 is where we react copper metal with silver nitrate. So we're going to just put a small volume of silver nitrate in a test tube, add a little piece of quite clean copper foil, and look really closely and make some observations. So let's go to the lab and do that, and then we'll come back and talk about what we saw and how that works in terms of redox. So here we are in the lab, and I've got a whole heap of copper cuttings, ribbon in this test tube, and it's beautiful, nice, shiny, people call it a pinky orange, gold coloured metal, I don't know, whatever you want to call it, bronzy coloured metal. Pop that there, and we're just going to add some silver nitrate. What I'm going to do is just add enough to cover all of the copper metal. Let's have a look. So straight away, if we focus, we can start to see some silvery grey solid forming in that test tube. It wasn't there before. That is all particles of silver metal that's collecting. We can also see that the colour of the copper is starting to go a bit dark because the silver atoms are all collecting on the surface of the copper there. I'm going to put it in the test tube holder. I'm just going to wait for a little while and see if we can make any more observations about what's happening here. We should ideally see a change in the solution colour. So we're going to pop it down and we'll come back to it in a few minutes. So here we are again. I've just given it a bit of a shake, and I've shaken a whole heap of those bits of silver off. There's the bell. But you can see that that solution has started to change colour. It's got a bluish tinge to it, so that's because of the free copper 2+ ions in that solution. So yeah, that's our experiment. So we're back from the lab, and here's what we saw. We've got some observations here. We can definitely say that the copper foil starts getting this kind of silver precipitate or silver solid forming. Right, this is kind of silvery grey. And if you did this and you looked really closely and you kind of did a comparison, you could also see that the blue colour starts to appear around this. So the solution starts to go from colourless to blue. Kind of looks like a bluey green or a pale blue. And so we'll talk about what that's because of. So when it comes to oxidation, the copper foil, copper atoms, have turned into a blue copper species, which is copper 2+. So that is what you're getting because of the blue colour, right? So you can actually observe that. For a copper to turn into an ion, it has to have lost 2 electrons, so we need to take them into account here. Here we go. So again, if you see electrons written on the right hand side, that's oxidation, or you see that this has had to lose electrons and have them come away, that's oxidation. Reduction. So we saw some silver grey solid forming. That is actually legit tiny little bits of silver metal forming. Silver atoms are coming together to form a solid. So knowing your ions, we know that we have an 81+ ion in solution, which is colourless in solution. That makes sense. And that is going to gain that atom is going to gain an electron. And turn into our silver solid metal atoms. All right, if we had to write these redox reactions together, here we've got 2 electrons being lost, but here we only have 1 electron being gained. So what we need to do is we need to double this equation so that we can cancel 2 electrons on each side of the arrow. So I'll do it here, like that. So we'd write just one of these, so 1 copper would be written. And what else is on the first side of the arrow? The silver ions, so we're going to have 2 of them. 2 electrons we won't write because they will be cancelled. So if we continue, we've got an arrow, and we've got copper and 2 silver atoms. All right. So now with the justification, again, you'll see there's lots of trends. We just have to say, why has this been oxidation or why has this been reduction? So copper has, a copper atom has lost 2 electrons. Losing electrons is oxidation, right? To form a Cu2 plus ion. You could justify this in terms of oxidation numbers. Any sort of element by itself, an atom, is going to have 0. And then a single ion is going to have an oxidation number the same as its charge. So the number has increased from 0 to 2. An increase in oxidation number implies oxidation has occurred. So Cu atom has oxidation number of 0, and this is increased to the oxidation number plus 2 in the copper ion, which also tells you we have oxidation occurring. Silver is nice because it started out as an ion, and we can see that it has gained an electron that has been in the solution to form the silver solid. So silver ion has gained 1 electron to turn into the atom. Again, a gain in electrons is reduction. Or we could use oxidation numbers. That's going to be a +1. That's going to be a 0. We have a decrease in oxidation number. So the Ag species has an oxidation number of +1 as the ion, and that's going to decrease to 0 as the Ag atom species. So a decrease in oxidation number means reduction has occurred. So yeah, do be mindful, like sometimes when we're explaining things, I'm not quite as careful with my language. It can be nice to just say the silver species, because that means that you're just talking about that particular form of silver. So here, this silver species, this is a silver ion. And then here it's changing from an ion form into an elemental form. So it's sometimes nice to say that this particular silver species, in this case the ion, has an oxidation number of +1, and it gains an electron to change into a silver atom species.